So guys, I'm gonna show the geometry textbook on the screen. Let's see. All right. So, well, you guys have to tell me what parts of geometry you guys know. So, like, if you guys could see my screen right now, do you know? Oh, okay. Why don't we do this? Let's see if you guys know how to do these types of problems. I guess we could take turns answering it. So let me see. The first one on my screen is Noble. So how would you answer number one, Noble?
The distance around a rectangle is called perimeter, and the distance around the circle is called the area.
Well, no, the distance around a circle isn't the area. It's the circumference. Mm.
Okay.
Mm. And then, well, I see that it says Bo, but I think your name's Eric, right? Yeah. So could you answer the second one?
Um, the number of square units covered by a figure. The number of square units covered by a figure is called its.
Well, you could think about what is recorded in square units. So, for example,
Area.
area. Yeah. Hmm.
Okay.
And then, well, now it's absolute value. It seems like. So, Nathaniel, do you want to try number three?
Okay. It's 2.
Yeah. Okay. Let's see the next. Okay, Wyatt, do you want to do 4?
That's 8.
Mm-hmm. Yeah. And then I think there's, or no, yeah, there's 4 of you. So, I mean, I think this part, it seems like you guys know this section. I mean, you could tell me if you don't. Do you guys want to go over this section, or do you want to go to later?
You go to later one.
Yeah, the skills in algebra check with like stuff we learned. I think.
Yeah.
Mm-hmm. Okay, so let's see the next. Well, do you guys know the difference between points, lines, and planes?
Mhm.
Yeah.
Yeah, everyone?
Yep.
Yeah.
Okay. Then I think that's what that lesson is about. Let's see.
Like the rays, the lines, and the. Okay.
I think this one's just talking about how to measure a line. Mhm. Then okay, do you guys know midpoint and distance formulas? No?
No.
Okay, so let's go over this then. So let's see. All right, so well, the midpoint of a segment is basically a point that's the same distance from both endpoints. It's like you could see on the screen. So for example, on the line AB, M is the same distance from A that M is from B. So it's exactly in the middle, and that's why it's a midpoint. And so you can see above, it says that the midpoint of a segment divides the segment into 2 congruent segments. So AM, I don't know if you guys could see my mouse. Can you guys see the mouse? Or just the
Yeah.
link?
So you can see
Okay.
them.
Well, so then AM here is the same length as MB.
Mhm.
Yeah. And then, well, I'm trying to cover the answer, but okay, well, it says in the skateboard design over here. I mean, you could probably see the answer, but try not to look at it, I guess. But it says in the skateboard design over here, VW bisects XY. Bisect means it divides it into two equal parts. And so it says VW, this line here, bisects the line XW at point T. So since you know it cuts it in two parts and it touches at point T, T must be the midpoint. Because if it's cutting it into two equal parts, that must mean T must be exactly in the middle. And so, let's see. Okay, so here it asks you to find. Okay, yeah, so it tells you the length of xt, and you know xt is the same length as ty. So then when it asks you to find the length of xy, you just multiply that distance by 2. You can see, so like, which is, yeah, that's what they did. So they know that xt equals ty, and xt is 39.9 centimeters. So the length of the whole line, xy, is 39.9 times 2, since these two parts of the line are the same length. Well, I guess I'll just go through the examples that they give, and then we could try some problems afterwards. So let's see, the second example, point M is the midpoint of VW. Find the length of VM. Okay, so like I was saying before, the midpoint is the same distance from both of the endpoints, which means that if M is the midpoint of VW, then VM must be equal to MW, which it's telling you the length of VM is 4x minus 1, and the length of MW is 3x plus 3. So you know that 4x minus 1 is equal to 3x plus 3, since you know these two lines are the same length. And so you can see that's actually what they do. They set it equal to each other and then solve for x. And so let's see, it asks you to find the length of VM. So then they just plug in x to 4x minus 1 afterwards. Okay, so let's try these then. Okay, so in exercises 1 and 2, identify the segment bisector of PQ, then find PQ. Okay, so I guess we'll go in order again. So Noble, do you want to try number 1?
Yeah, sure. So I just need to say what the segment bisector PQ is.
Oh yeah, you have to find the segment bisector of PQ, and then you have to find the length of PQ as well.
Okay, so I think the bisector is M, right?
Well, so the bisector is the full line. So it's not just M, it's MN.
Oh, MN. Okay, got it.
But if it's M would be the midpoint because it would be in the middle of the line PQ. But when it asks for a bisector, it's referring to a line.
Okay.
So the bisector would be whatever line divides it in half.
Okay, cool. And then PQ is wouldn't it be like 3 6/8? So like
Yeah.
rounded about 3 3/4.
Yeah, that's the answer.
Okay.
All right, so then on my screen, the next person is Nathaniel. So do you want to try number 2?
Okay. So number 2, it's 5. 8, 7.
So first you have to identify the segment that bisects PQ, and then you have to find the length of PQ?
The segment bisector is line L, right?
Yeah.
And PQ, well, PQ would be,
Well, so for PQ, it looks like you can't find the actual. You can't find an exact number for the length
Yeah,
since it doesn't give you any values. But you could figure out what the length is in terms of x.
okay.
Or no, I'm actually wrong. You can find the length.
Yeah,
hmm So this one is similar to this problem up here, example 2, where they knew that these VM was equal to MW, and they
yeah.
set them equal to each other. So that's similar to what you should do here.
So I need to write it down. Wait. Okay, I'm looking. Well, I got that. I know what x is equal to.
What did you get for x?
X is 18/7.
Mm-hmm. Yeah. And then to find the length. Well, so now that you know what x is, if you plug in x, you could find the length of both of those segments. And then when you find both of these segments are equal. So if you find the length of one side, then you just multiply it by 2, and that should be the length of PQ.
Um, the length would be like, it would be 82/7, I think.
What did you say?
The length would be almost like 82/7.
82/7?
Yeah.
Yeah. Okay, then let's see. Well, do you guys know what the coordinate plane is?
hmm
Yeah. It's just like the XY, the plane that's graphed with the X and Y axes. So let's see, now it's talking about the midpoint formula. So it says the coordinates of the midpoint of a segment are the averages of the x coordinates and of the y coordinates of the endpoints. So here they give you a formula, and you can see in the formula that basically if they're finding the distance between A and B, which have coordinates, so A would be at x1, y1, and B is at x2, y2. So what they did, they added the x values of both points and divided it by 2, and they added the y values of both points and divided it by 2. And that should give you the midpoint of the line.
Oh, okay.
So let's see.
Hey, hold on a minute, real quick.
Hmm?
Nothing, I'm good.
All right, so, well, here they do an example. They say the endpoints of RS are 1, -3, and 4, 2. Find the coordinates of the midpoint M. Well, I was going to ask one of you to do it, but it seemed like we could already see the answer, so we might as well just go over how they did it.
Hmm.
So if you look at the formula from before, you just add the x coordinates and divide by 2, and then add the y coordinates and divide by 2.
Mm.
So for A specifically, you could see on 1, so you add 1 plus 4, which is 5, and 5 over 2 should be the x coordinate of the midpoint. Then for the y coordinate, you add -3 and 2, and you get -1, and you divide that by 2. So then the midpoint should be at 5 over 2, comma, -1/2, which is, yeah, that's what they get here. Mm. Do you guys get it? If someone doesn't understand, say something. All right, so B. The midpoint of JK is 2, comma 1. One endpoint is 1, comma 4. Find the coordinates of endpoint K. So, well, without looking at this, what I first think of is I know that the distance from M to J is the same as the distance from M to K. But I'm also thinking of it. We could use the same midpoint formula, even though we're not using the two endpoints, we could somewhat work backwards. So we know that. Wait, let me see if I could get a whiteboard. Well, but then you guys won't be able to see the textbook at the same time. I think it's fine. Let's see. Okay, so, well, then I'll just write the information that was on the textbook here. So it said the midpoint of JK is M, and M is at 2, comma 1. And the line that M is the midpoint of is called line JK. And so, you know, J is at the point 1, 4. Yeah. So, you know, one of the endpoints is J, which is at 1, 4. And the midpoint of the line JK is M. And we know, so let's think about line K. We'll say that line K is at points X, comma Y, right?
Mhm.
And so we already know that the way you find the midpoint between 2 points, you add the X values and divide by 2, then add the Y values and divide by 2. So looking at this, the way you would find the midpoint is, and we already know the midpoint is M, but let's assume we didn't already know the midpoint and we're working with these variables. So then the X coordinate of the midpoint would be 1 plus X over 2, comma, 4 plus Y over 2. But see, now here's the thing. We do know the midpoint, so we know what each of these coordinates is equal to. So we could solve for X and Y. So, for example,
Um,
we could see that 2 is the X coordinate of the midpoint, and we know that has to be equal to 1 plus X over 2. So 2 equals 1 plus X over 2. So both sides multiply by 2. 4 equals 1 plus X, and then subtract 1 from both sides, and 3 equals X. And so you know that, well, so now you know that X equals 3 on point K. So we've solved that coordinate. Then when you solve for Y, you do 4 plus Y over 2 equals 1. Both sides multiply by 2. 4 plus Y equals 2. And so Y equals -2. And so we know that K must be at 3, comma, -2. And we could also verify right now by just doing the midpoint formula. So 1 plus 3 over 2 is equal to 2. which is the x-coordinate of the midpoint, and then 4 minus 2 over 2 equals 1, which is the y-coordinate of the midpoint, so it works. And then back to the textbook. Let's see. Well, yeah, see, it says the coordinates of endpoint k are 3, negative 2. Okay. So I think last time I didn't ask Wyatt. So Wyatt, do you want to try number 3?
Number 3. All right. Yeah. Hold on. Is it 4x and 10 y 10? Is it 4 and 10?
Yeah, 4 and 10. Yeah, 4 comma, or no, 4 comma 5, because, yeah, 10 divided by 2.
Oh yeah, my bad.
Okay, so then back to Noble. Do you want to try number 4?
Yeah, sure. Let me write it out.
Hmm?
I said, let me write it out, but yeah, I'll do it.
Okay.
Would it be 3 over 2, comma 1?
Could you repeat what she said?
3 over 2, comma 1.
I didn't get that. Wait, but let me just, I'm gonna write it out to make sure that, okay, so I'll bring up the whiteboard again. Okay, so what we know from this problem, it says the midpoint of line VW is M. I'm just writing mid for short of midpoint. And then, okay, so we know the midpoint M is at 1, negative 1, negative 2.
Right.
And then it says one endpoint is W, which is at 4, 4. See, W is at 4, 4. So, well, actually, no, but why don't you tell me what you did when you did this problem?
Okay, I used the nuclear formulas. So I added the x and the y value, and so I mean like the x1 by x2 and y1 by y2. So
Well, you do that when you have 2 endpoints. Because, for example, if you had V and W, you would do that and then you would get M. But now it's like you have to work backwards a little bit. So I'll show you what I would do. So
okay.
we don't know what the coordinates of V are right now. So we could call the coordinates of V X and Y,
Okay.
right?
Yep.
And so if we're trying to find the midpoint between V and W, that would be X plus 4 over 2 and comma y plus 4 over 2. But you see, whatever these 2 points are, they have to be the same as the 2 points over there.
Oh, okay, got it.
So
Okay.
now you could solve for x and y. So
Okay.
x plus 4 over 2 is equal to negative 1.
Right.
So x plus 4 equals negative 2, and x equals negative 6.
Got it.
And then you could do the same for the other side. Y plus 4 over 2 equals negative 2. Y plus 4 equals negative 4. And then y equals negative 8.
Okay, that makes
Then,
sense. All right. I got it like written down now, so I know how to do it now.
all right. Yeah, so those should be the coordinates for point V.
Okay.
Mhm. So let's see. Now it's going to talk about the distance formula. And so here you could see for the distance formula, which finds the distance between 2 points. In the diagram, you could see they use A and B. And so the way you find the distance between 2 points is so you could see they take the x coordinates. So they take the x coordinate of 1 point and subtract the x coordinate of the other, square it, and then do the same thing with the y values and square that, add them together, and then find the square root. So this is probably an important formula that you guys should write down if you don't think you'll be able to remember it.
X.
Okay, and it says, it talks about how the distance formula is based on the Pythagorean theorem, which is, the Pythagorean theorem is when you use, in a right triangle, so the side opposite of the right angle is called the hypotenuse. And so the Pythagorean theorem says if you square both, in this example, you could see if you square A and B and add them, you're supposed to get C squared. And so the distance formula is based off of that formula. Mhm. So does anyone not have this written down if they need it?
No, I got it.
All right. So standardized test practice says. Okay, so let's look at example 4. It says, what is the approximate length of RS with endpoints 2, 3 and 4, -1? Okay, so I think it's Eric's turn. So what do you think the length of line RS is?
Be 20.
Square root of 20.
Square root of 20.
Mhm. Yeah, which I would assume. Well, actually, which one do you think it is out of these choices then?
Of 4.5 units.
Yeah, I would assume that too. because the square root of 16 is 4 and 20 is more than 16 and less than 36, which would be 6 squared. So yeah, C. All right, let's see number 5. In example 4, does it matter which ordered pair you choose to substitute for x1, y1, and which ordered pair you choose to substitute for x2, y2? Explain. Do you want to try this one, Nathaniel?
Wait, which one?
Number 5.
Wow.
Yeah.
I'm confused on the question.
So, for example, if we use RS from the last problem, it's asking, does it matter if you do? Does it matter if instead, like so? For example, someone might say they'll do for this example, they plugged in x2 is 4 and y2 is -1. So this is considered the second point, and this is considered the first point. So this question is asking, does it matter if instead they said this was the second point and this was the first point?
Oh no,
So
it
for
doesn't.
example, yeah, no. Do you know why it doesn't matter?
They square it.
Yeah, that's why. Mhm. All right, so then back to Wyatt. Do you want to try number 6? Wyatt?
Sorry, hello?
Yeah. Do you want to try number 6?
Okay.
Are you having trouble, Wyatt?
Yeah, a little bit.
All right. So what did you do so far?
Well, I put the points. I put like the points in like the formula. I'm not sure like how to like dissolve it into the answer.
Okay, so you're saying you arrived at so did you get something underneath a square root?
Not as yet, no.
Okay. So okay, so you said you plugged it into the formula. So what is the what does it look like what you wrote down?
Um, Well, in parentheses, 1 minus -3, because that'd be the first one.
Mm-hmm.
And in parentheses, -4 minus 2 squared.
Yeah. You said 1 minus -3, right?
Yeah.
Okay. So when you squared those, well, did you square it yet? Or-
It should be 16 and -36, right? I mean, +36, right?
Mm-hmm. And then what 16 plus 36 is?
Um, 52, I believe.
Yeah, 52. And then, so which one of these answers would probably be the square root of 52?
Um, C. Okay.
Which one did you say?
C.
Well, I think it would actually be B. And the reason I say that is because if it's 52, you know that the square root of 49 is 7, and the
Oh,
square root
yeah,
of 6
it's 64. Yeah.
is 8. So, and we can actually check. Could you still see this other tab, guys? Yeah. Okay, so square root of 52. Never mind, half of my keyboard doesn't work, so I'll just have this on another tab. It might be useful.
Oh, definitely.
I'm trying to type square root, but the S on my, I could actually do this. It's 52. Yeah, see, it's about 7.2. But yeah. So I guess we could try and go through these. Let's see, back to Noble. Noble, can you do number 1?
Yeah.
Mm-hmm.
You can use. Am I supposed to answer like what you can use to get it?
Well, yeah, you answer what word belongs here.
Oh, okay. The distance formula.
Mm-hmm. Yeah. Okay. Oh yeah, that's number 2. I think is a good question. So Eric, could you answer number 2?
Um, bisect a segment basically means like you're making like well, I've seen this in like for degrees, like if you like two lines they bisect each other, like they make basically like a something out of 360 degrees. But I don't really know that question.
All right, so then, well, so to bisect a segment, you cut the segment in half. Like we were saying,
Yeah.
yeah, like the lines they had in earlier in the lesson, often the midpoint was, well, it has to go through the midpoint because if it's cutting the line in half, it has to go through the point in the middle.
Okay, yeah, because I got that confused with intersect.
And do you know why they say it's impossible to bisect a line?
No.
No. Okay, so so a line segment would be, well, like, so something from one point to another. But a line is at a line, if you just say a line, that means it's infinite. So for example, you see there's arrows at the end of these lines here. That means it goes on infinitely. So if it's infinite length, then you can't cut it in half.
Mhm.
And that's why it's impossible to bisect a line.
Okay.
Mhm. All right, Nathaniel, do you want to try line L bisects assignment? Find it. Okay, Nathaniel, do you want to try 3?
Okay. Oh. Then it's 10 and 2/8, or 10 and 1/4. Right?
Yeah. And then Wyatt, do you want to do number 4?
Okay. I believe it's 1 1/4.
VW, VW. Yeah. Yeah, 1 1/4, or 10, or 10/8, or 5/4. Yeah. All right. Well, so what I'm gonna do now, I'm gonna give you guys problems to do for homework, and then I'll probably just give you the problems they have up here. Let's see. 20. Or no, I see those are okay, and then probably these as well. Okay. Well, I think you guys will probably get this section anyway until number 8, so that's probably fine. And then RS bisects PQ at point R. Oh, and do you guys have access to this textbook?
Copy the link. Like,
Well, if you guys don't have access, I could just send it to you.
okay.
And then let's see, number 9, line RS bisects PQ at point R. Find RQ of PQ. Is okay. Okay. My uncle said he just emailed the textbook to everyone.
Cool.
And then so I'm gonna give you 9 and 10 look like it's the same concept. So we'll point T. So let's say I'll create a whiteboard so you guys could see what problems I'm giving you to do. Let's see. So I'll give you guys number 9. And let's see what else is on here. Each diagram M is the midpoint of the segment. Okay. I'm just looking through because I wouldn't want to give you guys too many problems, but enough so that you understand it. Okay. So let's say then we'll put 15 because that one's circles, which means that if you need help, they give an explanation in the book for that one. So 15. Um, yeah, and maybe add one more from that same category. So maybe we'll put like 13 as well. Then find the coordinates of the midpoint of the segments of the given endpoints. Okay, let's say 18 and 22. Okay, and then 23. 24. $29, $30. Well, I'm just writing the problems I'm thinking of. I might, if after I write them all down, it's too much, I might remove some.
Hey, what page is it?
This is page. It starts on page 19. Yeah. So let me write that on the.
Page 19.
Yeah, page 19. Mm. Find the length of some around. Then okay, we'll say 32. Okay, so 47 as well. Then okay, then 53. Mm. Okay, and then I mean I don't want to add too many more, so maybe we could do the mixed review next time instead of adding it to the homework. Let's see. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16. Okay, yeah, I mean, that's a good amount. All right, do you guys have this written down?
No, not yet.
Okay, so it's page 19 to page 22. Yeah.
All right. Okay.
So you guys are all in ninth grade, right?
Well, I'm going to 10th, so I'm in.
Okay.
But yeah,
Oh, so then you're in, so what school are you going to then?
I'm going to Baylor.
Oh, okay.
Yeah.
Mhm.